So today we're going to talk about probability distribution, where I'm going to be discussing discrete distribution tables and continuous distribution tables. Before we start, I want to talk about the relative frequency definition of probability. In Excel, when we're dealing with probabilities, especially with data sets, we take the frequency of a certain event occurring and we use that to calculate our probabilities. Right, so our discrete probability distributions. So for discrete probability distributions, we have two functions. The first being probability mass function, where for a discrete random variable, the probability distribution of the outcome is called probability mass function. And so that means the probability of, say we have a rolling die. So now the probability of getting a 6 is 1 out of 6. So we call the probability mass function of getting 6 when you roll a die is 1 over 6. Whereas a cumulative distribution function is the probability that a random variable assumes a value less than or equal to a specified value. In this case, the probability of rolling a 6 or less. That means it takes into account the probability of rolling a 6 or anything lower than a 6. Now we can see that in Excel ourselves to get a better understanding. So here we have an experiment set up where we have our events and the frequency of said events. So the frequency of us getting a 0 out of all these numbers would be 5 over 30. So we pull it down. So this is our probability of getting a certain event, or this is our probability mass function for each event. So the probability of getting a 4 would be 0.167. Now to get the cumulative distribution function of it, or the probability of getting something less than a 0 or less than a 0, in this case would be just itself, because 0 is the lowest number term that we have. So now the probability of getting 1 or less than 1 would be the addition of our probability of 0 plus the probability of 1. So then we can just pull it down and then we can find out that the probability of all of the probabilities. And I guess this can be used to also calculate the probability of, say, more than 4 or more than. So let's say we're looking for a probability of something that's more than 4. So what we can do is we can take 1 minus the cumulative distribution function of 4, and that would give us the probability of getting more than 4. So moving on. So now with continuous probability distributions, we also have our probability density function, fx, and we have our cumulative distribution function. We mostly focus with cumulative distribution function because in continuous probability distribution, we take the probabilities of a random of a value falling in within a certain interval. So everything is done within an interval, so we do not have the probabilities of an exact event occurring. We only have probabilities of an event of something falling within our range. And then most of the data that we will common examples of probability function, continuous probability, common examples of continuous probability distributions would be normal distributions, which we will be dealing in later videos, as well as exponential distributions. That's all we're going to be dealing with in this video, and the rest will be we'll go into more detail about distributions in the other videos.